Okay, in this video we're going to work through some problems from section 6.5 if you need a little bit more help with that. If you haven't watched the video explaining the information from 6.5, I highly recommend that you do that because we go through kind of the reasoning for all of these rules, which will help them make more sense. I'm just going to write the rules off to the side. You probably want to make sure that you have these handy. These are rules that I would have given you on the test, so I would just have them written down and keep them in front of you and make sure that you can use them. So the first one is the one that we used in the last video, log base a of a to the r is equal to r. And the second one is a to the log base a of r is equal to r. These are the two that give us, the proof of these give us that log and exponential are in fact inverses. So as long as the bases match, log base a and a will cancel out and you're left with r. A and log base a will cancel out and you're left with r. So those two kind of comprise the whole inverse property for log and exponential. The rest of these come from the fact that logs are exponentials, and they just come from basic exponential rules. So the first one is that the sum of two logs is the same as the product of the combined logs. So if you have log m and log n, you can put them together. Addition comes together as multiplication. Similarly, the other direction works. If you have the log of a product, you can break it up as a sum. The next one is that the difference of two logs corresponds to division or a fraction. So if you have log m minus log n, that corresponds to log m over n. These should look kind of familiar to you as exponent rules. If you add two exponents, if you multiply two exponents with the same base, you multiply two numbers with the same base. There we go. If you multiply two numbers with the same base, you add the exponents. If you divide two numbers with the same base, you subtract the exponents. Those are the rules that these came from that we talked about in the video. The next one is that log base a of m to the r. Okay, if we have an exponent inside the log, that's the same as an exponent or a coefficient outside the log. So an exponent in the log can come down to the front, and similarly a coefficient can come up as an exponent. All right, that one's kind of a funky rule that's special for logarithms, and it comes from rule number 3, that exponent means multiplication. We can break those all up as addition, and then it can come out front. So that explanation's in the video as well. And then I believe the last one, I feel like I'm missing one rule. If I'm missing one, we'll come back to it. We've also got the change of base formula that says if you have any logarithm with any base, you can change it to any other base using the change of base formula. Typically, we're going to change it to common log or natural log because those are more universal, and they also can be evaluated with a calculator. So typically, I'll just go ahead and change everything to natural log. In all the problems that we do, the bases are going to match. But when you get into calculus and stuff like that, a lot of times you're going to have maybe a common log and a natural log, and you've got to try to get them together. So you need to be able to get to one logarithm for the entire problem. We're just going to pretty much use it to evaluate on a calculator. But I can change this to any other log. And again, I'm typically going to use common log by writing log m over log a. So this number goes to the top, this number goes to the bottom. You can remember that because it's down low. So you can change this to any other logarithm as log m over log a, and again, I'll typically change it to common log. All right, and the explanation for all those is in the videos. I highly recommend you go back and check those out. So now we're just going to use these. Let's use these to evaluate a few logarithms. So let's say that we've got common log of x plus common log of y plus 3 minus common log of z minus 2. All right, so we're using rule 3 and rule 4. Addition comes together as multiplication. So I can put these together in one log as x times y plus 3. Okay, they come together as one log. And then subtraction becomes division, so this will be over z minus 2. So addition comes together as multiplication, subtraction comes in as division or a fraction, and I can put this all into one log. So a couple things to notice here. One is that all the bases need to match, and for our problems they will. Two, they all come together as one log, not log times log over log. Okay, that would be changing what operations actually do. So they come together as one logarithm with that matching base. All right, let's say we've got log 3 plus log x minus log 4 minus log z. Okay, now you can do this a few different ways in order of operations, but basically anything that is positive is going to go on top. Anything that is minus, that's division or fraction, that's going to go on the bottom. So I can put this all together as one logarithm. It's going to be 3 times x over 4 and over z. So the 4 and the z both go into the denominator. All right, so I could put the 3 and the x together, I could put the 4 and the z together, and then I can do the division and all that sort of stuff, but it's a whole lot easier just to keep it simple and say anything that's positive gets multiplied on top, anything that's negative goes into the denominator. Okay, so that's the basic idea for combining logarithms. Now let's do a couple where we break them up. So, let's do one with a coefficient first. Let's say that we've got like 2 natural log x plus 1 plus 3 natural log z. Okay, for this one, addition comes together as multiplication, but when you use these rules, they have to match exactly. This one doesn't match exactly. I've got coefficients, so I need to use property number 5 first to get rid of that coefficient, then I can use 3 or 4. So my first step is going to be to bring these exponents up, and I'm going to get ln x plus 1 squared and ln z cubed. So I've got natural log x plus 1 squared, natural log z cubed. Okay, so I'm going to bring those coefficients up as exponents. Now I can use property number 3 because now I match that property exactly. I can't use property 3 or property 4 when there are coefficients. So now using property 3, I can put this together. Addition comes together as multiplication. So I'd have x plus 1 squared z cubed, or you can write it as ln z cubed x plus 1 squared. Doesn't matter which way you write it. Okay, so if you have coefficients, you've got to bring them up as exponents using property number 5 first. All right, now let's look at expanding a few of these. So let's say that we've got, log base 2 of 3x over z minus 1. All right, so it may be helpful to first to decide what you have going on before you expand it, because it's easy to miss some things. So this is 3 times z, that's multiplication, over z minus 1, that's division. So I've got multiplication and division. So I'm going to use property 3 and property 4 to expand this. So I get log base 2 of, this is 3 times x, that's going to break up as addition. So 3 plus log base 2 of x. Okay, that breaks up as addition. And then this one's division, so it's going to go to subtraction, minus log base 2 of z minus 1. Okay, so multiplication breaks up as addition, division breaks up as subtraction, and they all get a logarithm. Every single term gets a logarithm. Now from here, I can't do anything because I've got log of z minus 1, and if you look at our properties, I can't do anything with addition or subtraction inside of a logarithm. Okay, in fact, in most of mathematics, that's pretty difficult to deal with. Addition or subtraction inside a logarithm or inside of a square root, not a whole lot that you can do with those. So I cannot simplify this anymore. This is my final answer. Now, one thing to note, a common mistake for this is to see the 3x and to see the z minus 1 like this. So this would be a common mistake because you just kind of think of 3x as one thing. So a lot of students will do log base 2 of 3x minus log base 2 of z minus 1, and that's not wrong, but you should always check your answer to see if there's anything else that you can possibly do. And if you check that answer, then you might be like, oh yeah, that's 3 times x. So now I can break that up as addition. And now I've got it completely expanded. So sometimes these take a few steps, and sometimes you don't get all of it in the first step, and that's okay. Just check your answer and see if there's anything else that you can do. Actually, we'll come down beneath this one. Okay, let's try another one. Let's say that we've got natural log of x squared y cubed over z to the 4th. And I want to break this up. So again, I've got multiplication and division. So the multiplication becomes addition. I'm going to have ln x squared plus ln y cubed. Okay, so multiplication becomes addition. Division becomes subtraction minus ln of z to the 4th. Okay, so I break this up as addition and subtraction. We're looking good here. Now when you expand out, you want to try to get rid of all multiplication, division, and exponents that you can. So we want to go ahead and keep going here. We're going to bring these exponents down to the front as coefficients using property number 5. And we're going to get 2 ln x plus 3 ln y minus 4 ln z. Okay, so check your final answer. Make sure there's no multiplication, division, or exponents that you can get to. And we look like we're in pretty good shape here. All right, let's try 2 more. I think I've got just enough time on this video. Let's say that we've got log of 5 times square root of x minus 2 over 3. Okay, again, we've got multiplication and we've got division, but now we've also got this square root thing that we don't really know how to deal with. But we do, because we talked about it in the last video. So we know that square root is an exponent, and we know how to deal with exponents. So you can either change it to an exponent now, or you can do the multiplication division and change it to an exponent later. Okay, so the order of operations here is kind of up to you. There's typically a few different ways to kind of tackle these. Let's go ahead and change it. Let's go ahead and change it to addition and subtraction first. So multiplication becomes addition, and division becomes subtraction. Okay, so we break that up. That's pretty similar to the last few ones that we did. Now we've got to make sure that we've taken care of all the multiplication, division, and exponents that we can, but we still have this square root here. So let's go ahead and rewrite that as x minus 2 to the 1/2. And now we know what to do with that. We know that exponents can come down to the front as a coefficient. So we're going to get log base 5 plus 1/2 log x minus 2 minus log 3. And again, sum or difference inside of a logarithm, we can't do anything with that, so we're going to leave that alone. We've gotten rid of all of the multiplication, division, and exponents that we can. All right, one last one. Let's say that we've got log base 3 of 9 times x squared plus 2. Okay, log base 3 of 9 times x squared plus 2. So this one has multiplication, and it has an exponent, but we can't really get to that yet, so let's just do the multiplication. So this is going to break up as addition. Like this. So we can break up the multiplication as addition. Whoops, and they both get log base 3. Log base 3, there we go. All right, so now we look to see if we can do anything else. So for the first term, can we do anything else? Log base 3 of 9. That should look familiar from 6.4. I can rewrite that with matching bases. I can rewrite 9 as 3 squared. If the base is matched, the log and the exponential cancel out, and I'm left with 2. Okay, so we can simplify the first one. The second one, I've got an exponent here, but can I do anything with this exponent? Can I bring it down to the front? Remember that the exponent has to go to the entire thing. The exponent has to go to the entire thing. So I can't do anything with this exponent here. As a matter of fact, I can't touch it at all because it's addition or subtraction inside the log. So there is nothing that I can do with this as far as the exponent or the addition.